paper called Benchmarking Uncertainty and its Disentanglement in Multi-Label Chest X-ray Classification. And as the scope for this video is quite limited, I'd like to give a overview of our about research, why I think it is important and useful, and then give a very basic overview of what we did without going into numerical details, etc. too much. So let's jump into our contributions. The title basically summarizes it kind of well. We did an extensive empirical benchmark across a multitude, 13 to be precise, uncertainty methods on chest X-ray data, which is the MIMIC dataset, for convolutional networks and vision transformers. You adapted some of these methods to fit the multi-label setting, and then most importantly, we analyze how well we can disentangle different uncertainty sources, namely epistemic and aleatoric uncertainty, using the information theoretical approach. So the motivation that sparked this paper is really that lots of theoretical and also theoretical very nice work out there in the uncertainty domain. So there's a multitude of different ways and many nice methods how we can derive uncertainty scores and how we can divide them, etc. But then there are often lack of really can be solved using the scores that we derived using our methods. So this is really the research gap that we wanted to fill here. So as I said, we're using information theoretical approach, so basically predictive uncertainty via entropy, aleatoric uncertainty via entropy, and then the difference of those gives us epistemic uncertainty. So no, aleatoric uncertainty refers to inherent data variation. Epistemic uncertainty is uncertainty due to lack of data. Yeah, we basically basically define 6 different tasks. One is OD detection, which is our for this we do corrupted samples and clean samples. So we took test samples, corrupt them via augmentations, and then see how well the scores can divide them into clean and corrupted samples. Then we have another task predicting ground truth uncertainty. Then we have 2 tasks evaluating how uncertainty scores evaluate influence correctness of prediction. And then we have performance, and then we also have a calibration task. Yeah, so here we have results across all tasks. Just a quick overview. We see for different tasks, different methods work quite differently. So different tasks, different methods are better some tasks than others. This is takeaway, and also architecture can matter, but I'll come to that again in a second. More interestingly, what we did with these tasks then is to evaluate how well epistemic and aleatoric scores align with the tasks they're intended to. So we can see how well aleatoric scores perform, how well epistemic scores perform, and then we see the difference or plot them like we did here. And we see here basically means that epistemic scores work better on the epistemic task than the aleatoric score. And we see this is not the case for each method. So what we can state here is that disentanglement not work in every method. Yeah, we also then have aggregated this into a nice overview plot where we can derive that ensemble-based methods are the best across disentanglement as well as aggregate performance scores. And as time is running low, I'll go to away from this paper. Really is that models as well as uncertainty methods need to be aligned with the tasks. Architectures matter, especially for ensemble remains the strongest generalist, even though expensive. And most importantly, we can say that the information theoretical approach to uncertainties, so disentanglement into epistemic and aleatoric uncertainty, while theoretically justified, does not hold empirical. Both types of uncertainty are strongly correlated, which you can look up in our appendix, for example. They are strongly correlated, even though they should not be, and they work not well on the intended tasks, even though they should be. So the way really is that we have to be careful when using information theoretical approach, as it might not hold up to its promise. Thank you very much. This was very brief, but I hope I could interest you. And if you have any questions, feel free to approach me. Thank you very much.